Alright, today's notes are on angle of elevation and angle of depression. The first goal is to be able to solve application problems using angle of elevation and angle of depression. I'm going to draw a right triangle here, and so we can define what these two things are. So right here is my right angle. Now, we'll talk about angle of elevation first. If you're standing down here, I'm going to draw a wonderful stick figure. You guys all know how good my drawings are. So if I'm standing down here and you're looking this way, that's angle of elevation. And so really you're looking up at this angle right there. Now theta is an angle, is a variable for an angle, just like x, but it's reserved for angles. So this is elevation. I'm just going to write elevation here, but it's angle of elevation. Alright. Well, it should make sense then that if I'm standing up here, yes, another wonderful stick figure, and I'm looking down at someone, that I'm actually going to look at them at the same angle they're looking at me. And so that's angle of depression. Now really what's happening here is that's really aligned to the horizontal. What's happening here is your angle of depression is actually right here. And I'm using theta again. Now I used red, but it turns out that this angle here and this angle here are equal to each other, right? So if I say angle of depression, I can put the angle here, but for trigonometry and a right triangle, whether I say angle of depression or angle of elevation, really what happens is it ends up being this spot right here, that angle. And the common mistake is for students to put the angle of depression here, which is wrong. So we'll do a little geometry review real quick. Whenever in geometry you saw something like this kind of Z, you said these are alternate interior angles, and these angles are then congruent. And this line here would be parallel to this line here. I know I have a lot of marks going on there. And before I forget, this is depression, or angle of depression. I'm just going to write depression here. Alright, so this first problem, the angle of elevation of the top of a mountain from the bottom of a ski lift is 33 degrees. The mountain is 545 meters tall. What is the distance the skier must ride on the ski lift to get to the summit? Alright, this looks like a lot of stuff, but what's going to happen here is we're always going to draw a right triangle. So let's draw a right triangle first. Alright, this is our right triangle. And of course this means a right angle, which I should have set up here, but you should be used to that from geometry. The angle of elevation is 33 degrees. Elevation goes right here. So we're going to label everything in our triangle. The mountain is 545 meters tall. So if this is angle of elevation to the top, this is going to be how tall, 545 meters, that the mountain is. What is the distance a skier must ride on the ski lift to get to the summit? Now that's going to be represented by this right here, and I'm going to call it distance. So we need to find that value. Whoa. Alright, now we're definitely going to use SOHCAHTOA, so let me write this over here again. SOHCAHTOA. We need to know what trig function we're going to use. So this is really right triangle trig. Alright, and so what do I have here? This side over here is opposite. Alright, and this side over here is the hypotenuse. So opposite over, so that's opposite over my hypotenuse is this. So I'm going to use the sine function. So the sine of the angle, 33 degrees, is equal to the opposite side over the hypotenuse. And now we got to solve this. All right, now when we solve this, this is very similar to fractions. We can cross multiply. So we're going to cross multiply d times sine of 33 equals 545. And then I'm going to divide by sine of 33. Let's finish this problem up here. So now I have D equals 545 all over the sine of 33 degrees. So we're going to do the rest of this in our calculator, so we'll get our calculators out. And the first thing that's really important is to check your mode. So hit the mode button, and right now I'm in radians. You can see right there radians, so I move over and down. And I get to degrees and hit enter. And now it's highlighted degrees. Then I go back to my home screen, and I'm going to type in exactly what I have here, 545, and then divided by sine 33. Close parentheses, enter. And so our answer here is our distance is going to be equal to, let me see that again, 1,000, we'll go ahead and round to 2 decimals, in 66 feet. So actually, I'm sorry, meters. 1,000. Point, we'll do 2 decimals, 66. And our problem was given in meters, so we'll put meters. This problem is done, so I can circle my answer. Alright, now let's get to the next problem. Example 2. The approach pattern to an airport requires pilots to set an 11-degree angle of descent. Descent is the same thing as saying depression. Alright, so we got to be careful how we read these. Towards the runway. If the distance measured along the ground between the runway and the plane is 52,800 feet, what is the altitude, height of the plane? So again, I'm going to draw a right triangle. Alright, so I'll draw it over here. We got this. Right angle here. Now the plane is really going this way in the air. Alright, I'm not going to try to draw a plane. And it says that they have an 11-degree angle of descent or angle of depression. Now remember from what I said above, that 11 degrees would go here. You want to make sure you don't put it here. And we said that angle is the same as the measure of this angle. And so really when you draw these, angle of depression and angle of elevation end up in this same corner of your triangle. All right, let's keep filling this in. If the distance measured along the ground between the runway and the plane is 52,800 feet. It's a big number, but that's 10 miles. So 52,800 feet. What is the altitude or the height of the plane? So we're actually looking for this, and I'm just going to use y. We're used to y going in the vertical direction. You can use whatever letter you want. The key is we're going to write SOHCAHTOA again. What trig function do I use? So SOHCAHTOA. And of course it's going to be based on the angle that you're at. And so we have opposite and then we have adjacent. So this is opposite and this is adjacent. And so opposite adjacent is TOA. So we're going to use tangent. So tangent of this angle, which is 11 degrees, is going to equal the opposite side, which we called y, over 52,800. All right, now this one's a little bit different the way we solve it. We still cross multiply, but the nice thing is when we cross multiply, we'll multiply this times this. We have 52,800 times tangent of 11. Always put the number in front of tangent so it doesn't look like it's inside the function. Equals 1 times y. And then I'm really solved. I don't have to divide because where my variable was. Alright, and then I'm going to get my calculator out. And so in this case, I'm just going to do 52,800, which is really 52,800, and then hit the tangent. I already know I'm in degrees from my last problem. 11, close parentheses, enter. And there's our answer. Alright, so in this case, y is going to be, we'll go ahead and do 2 decimals again. I've got 10,263.28 feet. feet. Now, the only thing I didn't use was a cosine. And remember, if you're given adjacent with a hypotenuse, then you would use cosine. And so this is our final answer. We'll circle it. Goal 2, to solve problems using arc length and area of a sector formulas. So what is arc length? Well, arc length has a little symbol S, and it's equal to R, stands for the radius, and theta. All right, now I'm going to go ahead and fill in some information on this drawing over here so we know what arc length is. This is called a central angle because the vertex is at the center of a circle. And so theta will be that angle there between these two rays. And the arc length is actually just from here. It's like this distance right here. I missed a little piece, but it's like the piece of the circumference. All right. The other formula then is area of a sector, and that's A for area equals half R squared times theta. And the key to this is theta must be in radians. So theta in radians. And what is a sector? The sector, and I'll highlight it here, is this shaded area right here, like a piece of pizza. So that's what the area of a sector represents. All right, so example 1. Find the arc length and area of a sector with radius 9 centimeters and central angle of pi over 3. I already have right here, theta is already in radians, so I can go ahead and use this formula. The most common mistake is not converting from degrees to radians. All right, so arc length is equal to my radius, which is R, and I should have put that up here. R equals radius. And so my radius is 9. I'm going to multiply that by theta, which is pi over 3. And we're going to reduce this, and I'm going to leave it exact. Now this is like a 9 over 1. So 9 divided by this 3, or 9 pi over 3, will reduce to 3 pi. And since this is a length, we use like just centimeters. And so that's the answer to arc length. So area of a sector, area equals, we have half, this is just straight from the formula, times R squared, 9 squared, times theta, which is pi over 3. And remember, these are all fractions, so this 9 is like over 1. So the area will equal 81 times 1 times pi, so 81 pi, over the bottoms, which is 2 times 1, which isn't written there, times 3, which is 6. And we can reduce this really quick. Now, what I like to do is just take 81 divided by 6. Don't get bent out of shape about the pi. I know radians are a little tricky at first, but they're just fractions with pi in the numerator. And if I just hit enter and math frac this, the calculator will do a lot of my work for me. Now notice when I typed it in, I didn't put pi anywhere in my calculator, so it reduces to 27 over 2. And so I'm going to write equals the 27 over 2 I got on my calculator, but I'm just going to put pi in the top. So when I typed it in my calculator, again, I didn't put pi in there. I kind of left it out just to reduce the fractions. So 27 pi over 2. Don't forget units. Now this is area, so it's centimeters squared. We'll circle that, and that's our final answer for area of the sector. Now, I kept these exact. Pi is in the answer. If I really want to know a decimal approximation, all I have to do is hit 3 times my pi key. I'm not going to do that here because I think it's easy just to leave it exact. All right, now what I want you guys to do is example number 2. It's very similar to number 1, except one thing. I'll give you the hint, and I highlighted it there. You're given the angle in degrees. Before you do this problem, you have to convert that to radians. All right? See you next time in class.